We will proceed in pseudo multivariate calculus in the calculation of the surface area. We are pursuing historical discussion in calculating the surface area through two different ways. One way is available in the book, and that is also not, the proof is not available. Only it is written material that is available in the book. What is surface area? If P is position vector to the surface area, then dP by dx cross dP by dy, dx dy is the surface area. This is written in the book. Whatever the proof they are providing in the book, only they can understand. Means that is the present scenario of the calculus. That's why generally people find themselves running away from the calculus. So we are here, we are taking responsibility now to proceed in the to proceed in a way that people would be attracted toward the calculus, making things logical and simple. Simple in a way that can we analyze a calculus problem without without calculus. If I have a mathematical problem, can I think this mathematical problem? Can I think this mathematical problem as a simple mathematical problem? And later, we will transform into the calculus problem. That is the concept, that is the mind-blowing idea. And one of them, the requirement is area vector. What is surface area vector? We are in phase to calculate the surface area vector. What we have seen till now, what is the surface area vector? Surface area vector. Consider this is a sphere. Repeatedly I am saying this is a sphere, or can I have different sphere? Okay, so I have another sphere. Okay, this is a sphere. Oh, it's very heavy. This is a sphere. Okay, if this is a sphere, then this is point P. Consider this is centered at the origin. Means center of this sphere is the origin, that is 0 comma 0 comma 0. If it is centered at the origin, then half of this sphere is above the xy plane and half of this sphere is below the xy plane. This is centered at the origin. Consider any point P out here. Any point P out here. P is x comma y comma z. If this is P, then if I go down here, then it will be x comma minus y comma, I'm sorry, it will be like x comma y comma minus z, because it is top hemisphere of this sphere is above the xy plane and bottom hemisphere of this sphere is below the xy plane. This is middle. Now if this is point P, from center of it I draw one vector. From the center of it, I draw one vector that is passing through P. The position vector of P is xi plus yj plus zk. This is P. What is position vector that we have seen till now? Please watch our previous videos. Trillion dollar, extremely, extremely, extremely precious. So if I have point P here, then what is the surface area? What is the surface area vector at point P? Through the modern way. If this is point P and it is centered at the origin, then surface area vector will be perpendicular at this point. Okay, this is surface area vector. This is surface, this is perpendicular at the surface. At any point P, what is the surface area vector? Okay, any point P surface area vector is dP by dx cross d. P is position vector, that is xi plus yj plus zk. dP by dx cross dP by dy, dP by dx cross dP by dy. This is the surface area vector. Not only this much, dP by dx cross dP by dy, bracket close, this is a vector. dP by dx cross dP by dy is a vector into dx dy. Full is called area vector. What is fundamental of calculating the surface vector is that if I have a position vector from center, if I draw a line and it passes through point P. If I have a position vector, then position, if I calculate derivative of position vector, that is d of P, that is the surface area vector. This is the modern philosophy. If I have a position vector connected from the center, and if I calculate derivative of the position vector, then this will give the surface along the surface fundamental. If I have, okay, I believe we have done it in a big detail. This is in synchronization with the concept that if consider this is in synchronization with the concept that consider this is origin and this is point P, that is x comma y comma z. From origin, if I draw a line like this passing through this point P, then that is called position vector, P vector. If I calculate derivative of this position vector, that will be tangent at that point, tangent vector. Position vector derivative d of position, I'm sorry, P vector, capital P on top of it, arrow mark. That is called P vector. P vector, if this is P vector, if this is P vector, then this is called position vector. If I calculate differentiation of the d of P, differentiation of P, it will give me another vector that will be along the line. If this is position vector, this is tangential vector along everywhere. Differentiation of position vector will be tangent to the line, means it will be along the line. Similarly, if I have very similarly, if I have a position vector like this P, from center of it, if I draw a line like this is position vector. If I calculate derivative of position vector, it will give me the along the surface another vector. That is d of P is the surface vector. This is what we want. What is the area vector? Area vector is nothing but d of P is the area. Are you sure about it? Certainly. It depends what position vector represents. If I took a curved line, then position vector was representing xyz was representing a curved line. If I take a position vector on the surface, then position vector represent a surface. Differentiation of position vector will give the surface vector along the surface. That is another thing, that surface vector is perpendicular to the surface, whereas line vector is along the line. But if position vector represent a curved line, then differentiation of position vector, that will be another vector that will be called line vector. If position vector represents a surface, then differentiation of position vector will give the surface area vector. Okay, d of P, d of P, where P represents the surface position vector, d of P. In similar fashion, if position vector represent a volume, then d of P will give more or less like a volume vector, whatever it is. This is how it is. So d of P, where P represent the position on a surface, then d of P will give the surface vector. Okay, d of P can be written as d of P by d of xy plane into d of xy plane. D of P by d of xy plane into d of xy plane. D of xy plane in the numerator, okay, and one is d of xy plane in the denominator. Numerator is d of P. What is this? Is full is area vector. Earlier area vector was d of P. Now area vector is d of P by d of xy plane into d of xy plane. Now full is area vector. D of P by d of xy plane is nothing but d. How much? How? Okay, so we'll proceed. D of P by d of xy plane. If this is xy plane and this is position vector on the sphere, d of P by dxy plane means on the xy plane. For xy plane, every point on the xy plane. Okay, it is very happy. Let's take this. For every point on xy plane, there is a matching point on this. If I take any point on xy plane and then I draw a vertical, it will hit something on the surface. With this point is x comma y, that is on xy plane, and the height, that is z, x, y, z. That is the point P. Okay. Now, if that is the case, consider there is any point here. Consider there is any point here x comma y, and from this x comma y I draw a vertical, and then it is going to hit this point. This point is x comma y comma z. Okay, this point will hit here, and this is x comma y comma z. Okay, if that is the case at x comma y on xy plane, if I move 1 unit of area, 1 unit of area, if I change 1 unit of area, there if I go 1 unit of area, then how many unit of area at point P here would change? Make sense? dp by dxy. On xy plane, if there is 1 unit of area, xy, there are two things. So there will be change in the area, not in the length, two dimension. dp by dxy. If if there is 1 unit of change in xy plane, how many unit of change I see in this plane? There are two planes if people see it. There is one xy plane, this is also area plane only. And there is one p plane, this is also area only. If on the xy plane, if I have a point called x comma y, and from that point, from that x comma y, from that point, if I go up and hit here, there is a point here called x comma y comma z. Okay, it will hit here a point called x comma y comma z. Now x comma y, it will go up and it will hit here point called x comma y comma z. In that case, from here, if there is 1 unit of area change on xy plane, correspondingly, how many unit of area change in the this plane? This is typically called dp by dxy plane. In the xy plane, if I make 1 unit of area change, how many unit of area change I see on this surface? If on this surface, if I make 1 unit of area change, then correspondingly, if it maps here, then at this surface, how many unit of area change I see? Okay, that is dp by dxy plane. I believe it is all right. So in that sense, we took at the point I took x comma y on the xy plane. There I proceeded on x-axis as x plus delta x comma y, and I proceeded on y-axis called x comma y plus delta y. Now in that sense, there are 3 points now. One is p1, that is x comma y, x plus delta x comma y, and one is p2, that is x comma y and x comma y plus delta y. There is pp3 also, that is x plus delta x comma y plus delta y. Similarly, that that rectangle that I am seeing on the xy plane, that rectangle has width of delta x and delta y. Because of that, the position p, from position p, how much I'll see the new rectangle is mapped. Makes sense? If there is a point on xy plane, that is x comma y, that point through function fxy, z height is function over x and y. Height is function over x and y. So fxy, if from there the fxy comes here, it's here. This is a point called x comma y comma fxy or z. Now, on the xy plane, if that point is x comma y, from there I am going along x-axis delta x, I am going along y-axis delta y, then it forms a rectangle which width is delta x and length is delta y. If I make a delta x into delta y rectangle from point x comma y, then that rectangle will go and map here. Okay, if point x comma y go and touch here at point P, then full rectangle will go and map here. Every point in the rectangle will map to some point here, and here it will make a shape. I'm not saying it will be rectangle, but it will make another shape. Okay, now in that sense, if I have, if this is point called P, Then there is another point here called P1. P1 is nothing but x plus delta x comma y comma function over x plus delta x comma y. There is another point called P2, that is x comma y plus delta y comma f function over x comma y plus delta y. That another point here P2, P1, P is x comma y comma z. P1 is x plus delta x comma y comma f x plus delta x comma y. P2 is x comma y plus delta y comma function over x comma y plus delta y. That is P2. Cross product of P1P and P2P will actually give the surface area that is mapped from the xy plane, delta x delta y. In that sense, what is P1P? P1P is x plus delta x minus x I plus y minus yj plus function over x plus delta x comma y minus fxy k. Okay, cross product with P2, that is x minus xi plus y plus delta y minus j, y plus delta y minus yj plus fx comma y plus delta y minus fxy k divided by delta x delta y into dx dy or delta x delta y. Now this cross product delta x I can take left side and delta y I can take right side. And left side become I plus fx plus delta x comma y minus fxy by delta x k. Cross product j plus fx comma y plus delta y minus fxy divided by delta y k. Okay, these two cross product, if I see closely, I plus fx plus delta x comma y minus fxy by delta x is dfxy by dx. F is a function f and then bracket x plus delta x comma y minus f x comma y by delta x is dfxy by dx, that is dz by dx, whole becomes I plus dz by dxk, bracket close, cross product with j plus dz by dyk, bracket close, into, I'm sorry, it becomes I plus dz by dxk, bracket close, cross product in bracket j plus dz by dyk, bracket close. Outside is delta x delta y, that becomes dx dy. This is the area vector. Now we are trying to find in a spherical coordinate system. If I calculate these two cross product, it will become minus dz by dx minus dz minus dz by dxi minus dz by dyj plus k, bracket close, into dx dy. This, if I am really trying to calculate area, then I have to calculate magnitude of this vector, or this can be used as area vector altogether. Like in calculation of flux velocity vector, when we are calculating the flux velocity vector, okay, when we are calculating the flux, then velocity vector dot product with the area vector is the net flux. Velocity vector dot product with the area vector. If I do dot product, then ijk will go away, whatever comes dx dy, this will be the net flux. But if I need to calculate the area altogether, then I am free to calculate magnitude of minus dz by dxi minus dz by dyj plus k. This magnitude dx dy, this is called area, calculation of the area. All right, but it is difficult. Dz by dx, where z equal to square root of a square minus x square minus y square, then it will be difficult. Now to talk in a spherical coordinate system, how we can proceed in a spherical coordinate system. In a spherical coordinate system, okay, if we finish the spherical coordinate system, it will not take much time now. For a spherical coordinate system, what we see is, if this is z, then a spherical coordinate system has three components. One is called phi angle with vertical. Phi angle is made and it goes till pi. And there is from horizontal, from x-axis, there is a angle, there is a radius, it moves and it goes to pi and the radius. If I have a sphere, If I have a sphere, if I have a sphere, then from the center of this sphere, if I take any point P here and draw a line that is called radius, and from the vertical, if I draw the radius, I believe it is all right. Okay, now from the center of the sphere, from the vertical, if I move the radius in the xz plane or yz plane or any z xy plane, I believe it is all right. Again, zx plane, zy plane. This is zx plane. This is x axis. This is y axis. This is z axis. This is zx plane. This is YZ plane. Whereas anything if I see like this vertical, then I can say this is ZXY plane. Means this is completely vertical and then it is going to hit XY plane, ZXY plane. Now, if I talk what we are talking now, now if I take this vertical Z axis from there, if I make phi in ZXY plane, phi will go pi degree, 0 to pi. This is another phi angle is another component of the spherical coordinate system. Or from x axis, if I move the radius like this in 2 pi, theta is the another component. In that sense, in a spherical coordinate system, it would be readily found in the book that x and Cartesian coordinate and spherical coordinate system. X equal to function over r theta phi, y equal to function over r theta phi, and z equal to function over r theta phi. Let's remove z right now and let's talk about x and y only. Okay, in that sense, let's talk about x and y only. If I talk in that fashion, x equal to kind of let's go with the xy plane and theta r plane. Right now, why I'm doing like that is that in a spherical coordinate system, I'm sorry, in Cartesian coordinate system, the variable in Cartesian coordinate system, the variable what we are taking is x and y only. Z is dependent component. It is not an independent component. In Cartesian coordinate system, Z is dependent component. I believe it is all right. Z is Z is dependent component. And whereas Z is dependent component and x axis and y axis, I believe I can give as an assignment how we can transform. Consider there is a position vector. Position vector is xi plus yj plus zk. We are trying two ways to calculate the area vector. One way is through the way I said d of position vector is the area vector. Now consider position vector. D of position vector is the area vector. If if position vector is xi plus yj plus zk, then dp by dx cross dp by dy into dx dy is the area vector. This is what we have seen. Consider position vector is in xyz, where x equal to r sine phi cos theta. This is Cartesian coordinate to spherical coordinate system conversion. Consider it is x is r sine phi cos theta, y is r sine phi sine theta, where z is r sine r cos phi. This is written in the book. X is r sine phi cos theta, y is r sine phi sine theta, z is r cos phi. If that is the case, then how we can proceed in a spherical coordinate system? Because if I change x as now, our position vector becomes r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. Okay, d of this position vector by dx will not work. The area vector is dp by dx cross dp by dy, dp by dx cross dp by dy. Okay, in that sense, p is in r theta and phi. By dx will not work. By dx will not work. Earlier we showed that dp by dx cross dp by dy, okay, into dx dy, dx dy is the net area vector. But right now it doesn't look like so. Okay, dp by dx cross dp by, how, if position vector is r, theta and phi, then how we can proceed in the spherical coordinate system. Let's see another way. Another way is our pseudo multivariate calculus way. Pseudo multivariate calculus say that if you try to find area vector of a flat area, then this, consider this is origin and this is a vector and this is b vector. If you calculate cross product of a vector and b vector, then it will give the area vector. If this area vector is not flat, it is curved, then this a vector become a curve vector and b vector also become a curve vector. Still, I can say this curved line can be represented through a vector and this curved line can be represented through b vector, where a vector now represent a curved line. If a vector represent a straight line, then this is xi plus yj. If b vector represent a straight line, that is xi plus yj. But if a vector represent a curved line, please watch our previous video. If a vector represent a curved line through pseudo multivariate calculus, this xi plus yj, I have to take out x or y to make it a curve vector. So A cross B is the surface area vector when it is a flat surface. In A, I take out x, and in B, I take out y. So here it becomes I plus y by xj into x. Okay, cross product x y y I plus j bracket close into y is the b vector. Or if I talk about x y z, then first is I plus x I plus y by xj plus z by xk bracket close into x. Cross product with the xyyi plus j plus z by yk bracket close into y. If I do this cross product, this is the new area vector. Okay, if that is the case, I take out x from the a vector considering it is toward the x-axis and another toward the y-axis. I took out y, but both are indeed xi plus yj plus zk only. That is the length vector primarily. Anyway, length vector first. If I change division to differentiation. This is the way we are proceeding into the pseudo multivariate calculus. Division, I'll change it to differentiation, and multiplication, I'll change it to integration. Then it becomes cross product of I plus dy by dxj, dy by dxj, mind it, I plus dy by dxj plus dz by dxk bracket close into dx, cross product with dx by dy plus j plus dz by dyk bracket close into dy. Okay, if that is the case, let's try to find out the surface area vector through multivariate calculus. If I take any point P here, then I'll make a cut in the xz plane. And if I take any point P here, I'll make a cut in yz plane. Then if I make a cut in xz plane, it will make a circle. And if I cut in yz plane at any point, it will make another circle. Okay, if it makes a circle in xz plane, then circle the line, the circular line, that is the curved line, for which I know the formula. What is your formula in that? That is I plus dy by dxj plus dz by dxk bracket close into dx. If it is yz plane, then it is dx by dyi plus d plus j plus dz by dyk bracket close into dy. Anything I can take, because both are same only. I have taken out x1 and taken out y1. Now in xz plane, y is constant, y is not varying. In yz plane, x is not varying. So first dy by dx will become 0, another dx by dy will become 0. Now in that sense, it becomes I plus dz by dxk bracket close into dx cross product j plus dz by dyk bracket close into dy. Okay, you were talking about a spherical coordinate system, right? Okay, now let's write into spherical coordinate system. In a spherical coordinate system, it is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. If that is the case, if that is the case, then in first cross product be the same thing. R sine phi cos theta I plus I. This is A vector and this is B vector. If I cut this in xz plane and yz plane, if I cut this in xz and yz plane, what are the two variables we are saying? If I am talking about, if I am talking about a kind of, if I am talking, if, I'm sorry, if I am talking about the spherical coordinate system, okay, then there are two independent components. One is called, if I am talking about the area, if I am talking about the area, then r is constant, radius is constant. If I am talking about the area, then radius is constant everywhere. Only thing varying is phi and theta. Radius is constant at all the where in the surface of a sphere. Radius is constant. If that is the case, then one place I'll take out theta out and one place I'll take out phi out. This is the pseudo variate calculus. What is your kind of fundamental? That is r sine phi cos theta I, r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. If I take out theta out, then it becomes r sine phi cos theta by theta I plus r sine phi sine theta by theta j plus r cos phi by theta k, bracket close into theta. Cross product, there r sine phi, there I am taking out phi, r r sine phi by phi into cos theta I plus r sine phi by phi sine theta j plus r cos phi by phi k, okay, into phi. Now if I turn this division into differentiation and multiplication into integral calculus, then it becomes, first will become r sine phi d cos theta by d theta I plus r sine phi d sine theta by d theta j plus r cos r d r cos phi by d theta means 0 because there is no theta there. So it becomes r sine phi minus sine theta I plus r sine phi cos theta j, bracket close, d theta cross product with another one, that is r r cos phi cos theta I plus r cos phi sin theta j plus r minus sin phi k. Someone has to calculate the cross product of these two and let's see what it comes. Okay, we will try in another session. Okay, and outside d theta, if I settle it down, then whatever cross product vector comes, it will come as a new vector. Whatever cross vector comes, d theta d phi, this is the best thing that anyone can imagine in the world. So nicely we got the area vector, or we can try r I'm sorry, r r sine phi cos, this is I j, and that side I j and k, I cross I 0, I cross j will be k vector. So let's first settle down the k vector. Now I cross j, here it is r sine phi and there it is r cos phi. Okay, and then there it is sine theta, here also sine theta. So it will become r square sine phi cos phi minus sine square theta k. Okay, now second term is j and in this side I. If I do cross product, it will also become k minus. Then it becomes r square sine phi cos square theta. If I settle it down, it becomes r square sine phi cos phi, r square sine minus r square sine phi cos phi k. So k vector is settled, r square sine phi cos phi k. Let's get the I vector. To get the I vector, I and j, that side I, j and k. If, okay, if j and k will cross, it will give the I. Okay, j is r sine phi cos theta and there it is r r sine phi. It becomes r square sine square phi cos theta I. Similarly, it will be r square sine square phi, r square sine square phi sine theta j. I believe it is all right. Okay, this side j, this the first cross j is r sine phi cos theta, and that side k is r sine phi, r sine phi. It becomes r square sine square phi cos theta I. Similarly, it becomes r square sine square phi sine theta j plus r square sine phi cos phi k. Okay, this is the area vector. Minus is coming outside. So minus I can just keep it. Now it becomes r square sine square phi cos theta I plus r square sine square phi sine theta j plus r square sine phi cos phi k bracket close d theta d phi. This is the area vector. If someone is really trying to calculate the area vector, someone has to find the magnitude. In that sense, r square sine square r to the power 4 sine to the power 4 cos square theta plus sine square theta plus r to the power 4 cos square phi sine square phi. First two will become r square r to the power 4 sine to the power 4 cos square theta sine square theta will go away. And another will become r to the power 4 cos square phi sine square phi. In that sense, r to the power 4 sine square phi I can take out. It becomes sine square phi cos square phi 1. At the end, if I take a square root, it becomes r square sine phi d theta d phi. If someone calculate r square sine phi d theta d phi, phi is 0 to pi and theta is 0 to 2 pi, he will get the surface area of the sphere. Mind blowing, amazing. This is a spherical coordinate system surface area. Spherical coordinate system surface area is what we did. We took the position vector, that is x, that is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. In that I took out theta. I took out theta to make the this vector as, I'm sorry, what we did when we try to calculate this, when we try to calculate the surface area vector, I cut it in xz plane, I cut it in yz plane. In xz plane, if I cut a sphere, it will resolve into a circle. Circle is nothing but a curved line. Curved line, any line vector can be represented as xi plus yj plus zk that we have seen. Okay, to make it vector representation of a curved line, I take out x. Similarly, in yz plane, the vector representation of any curved line is xi plus yj plus zk. Here I take out y, considering that the surface area what we are calculating, x-axis and y-axis are independent components. If I cut in xz plane, then this is x-axis and this is z-axis. Z-axis is dependent upon x-axis. If I cut in yz plane, this is y-axis and this is z-axis. Z is dependent upon y, means z is dependent upon y. So if I represent this curved line as a curved line vector, then I'll take out x, that is independent. Please watch our previous videos. If I try to represent this curved line, then I'll take out y as independent component. Similarly, if I'm trying to find the vector surface area representation in theta, phi and r, where r is constant and theta and phi are variable, then first I'll take the first, then the way I cut it into two and then I took the cross product. To calculate the surface area, I need to take cross product of two line vector. If you see the curved surface area, still I need to take cross product of these two lines. This curved line is the curved line circle in xz plane. This curved line is the curved line of a circle in yz plane. If these two curved line, if I do cross product, then that will give the surface area of the curve. That what is your curve? Curve is this curve. I believe it is all right. This is the curve. This is the curve. If I try to find the surface area of this curve, then this is the curve which has one side as a curve line and another side as a curve line. Curve line vector can be represented as x, y, z only, but I have to take out x. Another curve line I can represent it as xi plus yj plus zk only, but I have to take out one of the independent variables. I take y. Similarly, if I talking about the spherical coordinate system, the independent component is theta and phi here. R is not dependent, but it is a constant. It is not a variable. In that sense, the two curve line, the way I am cutting it, xz plane or y, the two curve line what I am taking, one is xi plus yj plus zk, another is again xi plus yj plus zk. One is r sine phi cos theta I plus o, means I am substituting x with the theta and phi. And another is again r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. One side I take out theta to make this line as a curve line vector. Another side I take out phi to make this curve line as a line vector as a curve line. Then I do cross product. Then it comes as r square sine square phi cos theta I minus r square sine square phi sine theta j plus r square cos phi sine phi k, bracket close, d theta d phi. Okay, this is surface area vector. If someone calculate the magnitude of it and then integrate with d theta d phi, theta is 0 to theta phi is 0 to pi and theta is 0 to 2 pi. Indeed, he will get the surface area, that is 4 pi a square, 4 pi r square. Certainly, 100%. Someone can try. R square sine phi integration is cos phi minus cos phi. 0 to pi means 2. R square 2r square, and d theta is theta 0 to 4 pi r square is the surface area. This is through pseudo multivariate calculus. Whatever we started discussion in the conventional way, the surface area is d of position vector, or dp by dx cross dp by dy into dx dy. That was through Cartesian coordinate system. How I can proceed in a spherical coordinate system, that we will see. Okay, what you will see, that should come, that through that way also the surface area vector should come as r square sine square phi cos theta I plus r square sine square phi sine theta j plus r square sine phi cos phi k. If it comes, then our pseudo multivariate calculus fundamental is all right. Anyway, that we will see. Please do not mind supporting us. +91 is the India country code, 94831 60610 is the telephone number. 91 is the India country code. 94831 60610 is the telephone number.